On this section, we're going to talk about getting information from the graph of a function. So whatever function that we have graphed, always pay attention to the labels on the x-axis and on the y-axis, because that will give us a hint of what it is that we're talking about. Now, in this example, it says the function t graphed in figure 1 gives the temperature between noon and 6 at a certain weather station. So I know that this is temperature, and I notice the temperature is in Fahrenheit. And then the x-axis varies between 0 to 6. Now, this says noon, which is 12, to 6 p.m. So I have to understand that the x values have been transformed. Noon is being represented by the number 0, and then on my graph, x equals 1 will represent 1 p.m. And then I can say, 6 will represent 6 p.m. So in here, the x varies from 0 to 6, but that actually represents all the hours between noon and 6 p.m. So part A says, find t of 1, t of 3, and t of 5. Since t doesn't have a function, then I can't evaluate simply and find that value. I have to use my graph. Since I'm going to use my graph, I'm going to do the best in approximating why that is. So remember that t of 1 represents the y value when x is 1. So when x is 1, this is the point on the graph, so the y value is 25. Then I'm going to do the same thing for t of 3, that is 30, and then t of 5. And that is actually 20. Now it says part B, which one is larger, t of 2 or t of 4? Now, this is not really asking to find t of 2 or t of 4. I could, but just because the values are located in this manner, t of 2 and t of 4, I can see that clearly t of 2 is higher than t of 4. So I can answer that right away without having to find any y values. Now part C says, find the value or values of x for which t of x is 25. So when I'm finding something like this, what I've been asked is, if the y value is 25, how much is x? So on the y's, I'm looking for the number 25, which is right here, and then I'm going to draw a line across. And then I'm going to see how many times my graph is being intersected. I see that my graph is intersected at 2 values right here. So I know that there are going to be 2 x values for which the y is 25. One of them is 1, and the other one is 4. So those are the 2 x values. Now, notice how they don't ask me for what times the temperature is 25, because that could be the equivalent question for this. They could ask me for what times in the afternoon the temperature was 25. So I could say, oh, it happened twice. One of them happened at 1 p.m. and the other time was at 4 p.m. But they don't ask me that. They just ask me for the values of x, so this is good enough for this part. Now part D says, find the value of x for which the temperature is greater than or equal to 25. So the temperature is greater than or equal to 25. That means I want to know when the temperature is more than 25, maybe 26, maybe 27, maybe 28, and so on. So I can see that this portion of my graph actually fits that criteria. The temperature is at least 25 or bigger. So for what values of x I have that? So if you can see that I can limit my window here manually, you can see that the temperature is above 25 for x's that are between 1 and 4. For x equals 1.5, 1.6, 1.7, 2, 2.5, 3, and so on, the temperatures are much higher than 25. So I can say that not only 1 and 4, but every x between 1 and 4 fits that criteria. So what I'm given is an interval all the values, because not only 2 values of x, but infinitely many, all the numbers between 1 and 4 actually fit that criteria. So I can say between 1 and 4. So I can write my answer like this, or I can write my answer as interval between 1 and 4. This way is faster, but you have to be fluent on both. Now, on the second slide says, the graph of a function helps us picture the domain and range of the function on the x and the y axis. So remember, x-axis, that's where I see the domain. Y-axis, that's where I see the range. So the domain is seen here, the range is seen here. Now, I could use the same piece of paper that I had before. And if f starts and finishes, then I can say that the domain is between this x and this other x. And now for the range, I want to know all the y values that I'm using. So you can see that the lowest value that I'm using is this one, and the highest value that I'm using is this one. I know that my function ends here, but that's okay. I just want to know all the y values that I'm using. Now you can see how these y values are being used twice, not only for these points but all these points. But that's okay. I just want to list all the y values that I'm using, whether if I'm using them once or twice or 3 times, that's irrelevant. On example 2, it says find the domain and range from a graph. Part A says using a graphing calculator to draw the graph of square root of 4 minus x squared. Now, you turn on your calculator. If you have a graphing calculator with you, that will be good. I recommend that you should purchase it. But if you don't, that's fine. You can wait until you come to class to do this part. It would be nice that you listen and you write down notes so that you can go back to it. You don't have to watch it again. So a square root, and then I'm going to put 4 minus x squared. Now, when I graph it, if I don't see a nice view, it's always useful to say, okay, I want to use a standard view which will show me x's from negative 10 to 10 and y's from negative 10 to 10. That window is always found at zoom 6. A standard zoom will give you that. So now I see that it's like half of an oval. However, I'm fitting here 20 units, and this way I'm fitting 20 units. So this graph is actually distorted. This is not the real shape. I'm not looking at half of an oval. I'm looking at actually a half of a circle. Because I don't know if you remember, if you have x squared plus y squared equals 4, this is the equation of a circle of radius 2, center at the origin 0, 0. When you solve this equation for y, what you get is y squared equals 4 minus x squared, because you will have 2 minus x squared both sides, and then finally you will take the square root, but you're going to have a plus of a minus, because that's what happens. You always get 2 answers whenever we have something square. But since you're seeing the positive root, you only get half of a circle rather than the entire circle. This is the positive square root of 4 minus x squared. This will be the negative square root of 4 minus x squared. So you see that this is only part of a circle, and it looks distorted on my calculator just because the scales are different. In here I have 20 units. This way that is shorter, I'm fitting the same 20 units, so a unit here looks different. So using the calculator, you know that you're gonna get something like that. It's not gonna be an oval, it's gonna be a circle. If you use table, then that will give you some values that you can see. As you can see on my table, everywhere else I'm not gonna get a y value. So x equals negative 5 says error. That means negative 5 is not part of the domain. So I can't use negative 5, I can't use negative 4, I can use negative 2, and that will be 0. So I know that will be the point here that I'm using, negative 2, 0. Then the other point that I have is negative 1 and a decimal. I probably don't want to graph that. The next one I can graph is 0, 2, and that will be right here. And then the next one that I can graph, it would be 2, 0. So as you can see, it's half of a circle. Okay, so I use the graphing calculator to graph it, and now I'm gonna find the domain and range. Since I have the graph, I don't have to use any algebra in here. I can just say the domain are all the x's between -2 and 2. So the domain is between -2 and 2, closed. Now the range, I can say every point in here is using a y that is positive all the way up to 2. And I'm even using y that are zeros. So the range is from 0 to 2, both ends closed. Now on this part, for any graph, it's always interesting whenever we have portions where the function is increasing. Let's say that I'm trying to figure out some kind of variable that influences my grade, then I want to know for what values of that variable my grade is going up. Sometimes it's interesting to look at a graph and find out where the function decreases. For example, I want to know, I'm paying for school and I want to know what is my cost of going to college decrease. So whenever we're looking at a function, it's always interesting to find where it grows and where it decreases to make certain decisions. Now, as you can see here, if my graph is defined from A to D, in part of it is increasing and part of it is decreasing. Whenever we have a function, please read it from left to right, just the way we read English, because you can say, oh, f is increasing here, but if I go the other way, it's decreasing. So which way is it? Always from left to right. So my finger goes up, it's increasing. My finger goes down, decreasing. My finger goes up, increasing. So I have, on the domain, I have 1, 2, 3 intervals where the function behaves differently. In here, f increases on the interval from A to B, whatever those numbers are. If it's 1 and 5, then you will say 1 and 5. What happens between B and C? F is decreasing, F decreases, and that will be between B and C. And then between C and D, my function is increasing again, so I will add that interval to my part where I'm saying that f increases. So this is the way to describe this graph. If I don't have this graph anymore, I know that my function goes up between these two values, goes down between these two, and goes up again between those two. So this is information that will describe the graph whenever I don't have a graph. So in general, you're always going to encounter, whenever you Google Math help, you're always going to encounter formal statements about it. So it is important that you learn how to read statements like this without getting confused with it. It says f is increasing on an interval I. This is just a name for the interval. If this means this is the y when x is x sub 1. This is the y when x is x sub 2. So right here, if this is x sub 1, this point will be x sub 1, let's say y sub 1. So in general, if this is an x and a y, you get the y by plugging in x sub 1 into f. So that's what it means. This is the y value for the first point. This is the y value for the second point. And if the y value for the second point is larger than the first one, then we say the function is increasing on that interval, as long as the x, the first x that you have, is less than the second x. So f is increasing if you notice that you have 2 points. If one x is less than the other, then the y for that point has to be less than the other y. Now f is decreasing whenever you have 2 points. If one x is less than the other, then the y for that x is actually bigger than the other y. This is the y for x sub 1, this is the y for x sub 2, and you can see how the y for the first point is actually higher than the y for the second point. So when that happens, we say that the function is decreasing. Now in example 3, we can see how if I follow this graph, my picture goes up, goes straight ahead, goes up, goes down, goes straight ahead. So there are 3 different behaviors: going up, going straight or staying steady, going up, going down, and steady again. So it says determine the intervals on in which the function is increasing and decreasing. So increasing, you know where the finger is going up, so I know that it goes up from here to here. So the intervals in which it's increasing, I'm only looking at the x values. Okay, so on the x values, that would be from 0 to 20. So I can say it increases from 0 to 20. Now the other portion where it goes up is right here. So again, I'm only looking at the x values to describe that. So that would be between 35 to 40. And that's it. Now decreases on the interval, let's see, from 40 to 50, and then in another interval. If you want to talk about the intervals between 20 and 35, or 50 to 80, then you will have to say the function is constant. So f is constant on those intervals because it's neither increasing or decreasing. I know that I promised to keep it short, but we won't meet until next Tuesday. So let me just continue. I promise I'll cut off at 20. So it says sketch a graph of the function. This is a polynomial of degree 4. And I'm going to find the domain and range of f, and I'm going to find the intervals on which f increases and decreases. So for any function, it's always useful to find out where the intercepts are. So in here, I know that when x is 0, f of 0 in here, the y is 0. So I know that it crosses the x-axis there, it crosses the y-axis there. So I'm going to enter my function on the calculator the way you see it here, with the correct exponents, and then I'm going to graph it. You're going to see the general behavior, and you should have this window on just to see from far away. Now I can see how the function is increasing here, decreasing, increasing. There is no gap in here. The only thing that's happening is that the graph is going off this screen, but it continues and then somehow it comes back down. So in here I'm not seeing the entire function. That means I do need to see more y's, but you do realize in here that I'm looking at enough x's because I can see where this function is crossing the x-axis in both ways. So I'm going to have to adjust my window a little bit, and I can do that by adjusting the x's. I don't want to see so many x's, so I can reduce this to -8 to 8, but I do want to see more y's, so I can change this to 20. Maybe that will do it. So you'll graph that, and now you see how you can see more x's, but you still cannot reach the actual top of this. So that means I'm going to have to see more y's. So if 20 doesn't do it, then maybe 50 will do it. So when you graph, you can see how, oh, 50 was good enough. Maybe I could have gone to 40. So I see the function increasing, then decreasing, then increasing again, then decreasing. So this will be a good sketch for my graph. So it increases, decreases, increases again, and decreases. Now the key thing here is to find the actual coordinates of these points, because if I'm talking about the range, then I want to know what is the lowest y and the highest y that I'm using. As you can see, this function continues down, because if I go to my table and then I'm looking at all the x's that are very negative, the y's are going to become even more negative. Like for example, in here I have -1 times 10 to the 6th power, that's -1 million. So in here, as x becomes more negative, the y's will become even more negative. So this doesn't stop, it continues all the way to -infinity, and so does this part. But at least I would know what is the highest value that I'm using. So to find the coordinates of these high points, I'm going to use the following on my calculator. Oops, sorry. Alright, so I want to know the highest point here. So I'm going to use my function calc. Because calc is in blue, I press second on that, and then I'm trying to find, I'm going to use the maximum. Now, this is the way the maximum works. The maximum will find the coordinates of the highest value of anything. Now, the calculator is going to ask you three things. It's going to ask you, if this is the maximum, give me a point on the left of the maximum. The other thing the calculator will ask you is, give me a point to the right of the maximum. And then the calculator is going to ask you a guess. Now, for the guess part, you don't have to worry about it because it gives you a default guess. So let's do it. I go to calc, I choose maximum, and then the calculator is asking me, what is the left bound? Which means, what is the left side of this maximum? So you see the maximum is here. This is to the left. You could press enter here, or maybe here, or maybe here. It doesn't matter. You just have to be on the left side of the maximum. So I'm going to press enter. Now the calculator is going to ask me for the right side of the maximum. Now, if this is the maximum, the right side is over here. So you just have to move with the arrows to the right side of the maximum. It could be here, or it could be closer. It doesn't matter. Press enter. And now the calculator is asking you for a guess. You leave it alone, just press enter again. So the calculator is giving you the coordinates of this point. Now it's giving you 1.99999. Because it's so close to 2, I'm just going to simplify to 232. Oops. So I know the coordinates here are 232. Okay. Now I could get the values for here. But if I'm doing range, it really doesn't matter. I just need to know the lowest y and the highest y. So the domain for f, as we can see, we're using all the x values, so the domain would be from -infinity to infinity. But the range, I'm using all the negatives all the way up to 32. Closed. And B is done. Now part C says, find the intervals on which f increases and decreases. So for that, I do need the coordinates of these points. So now I'm going to do it again. I'm going to go to calc, pick maximum, and now I'm trying to do it for this point. So I'm going to go to the left of that point. Could be there. Now to the right of that point, could be there. And then the calculator will give me -1, 5. So the coordinates here, -1, 5. And then the lowest point, for that I'm going to use minimum. So calc, now minimum, 3. So again, the calculator is going to ask me to be to the left of that minimum, maybe there, to the right of that minimum, maybe there, and then guess, leave it alone. And it's going to give me the coordinates of this small value. Now this is 4.7 times 10 to the -7. That is 0. So in here, the lowest will be 0, 0. So now I can answer part C. What are the intervals for the function to be increasing and decreasing? So for increasing up to here, so it's going to be from -infinity to -1, because that's the x value. I don't care about the y values. For increasing -infinity to -1, and then from 0 to 2. And now for decreasing, it decreases in this part, so it's from -1 to 0, and then after 2 and on. So after 2 and on to infinity. and I'm just finding these values and then I'm using those for my intervals, and that's it.